So the reason why graphing and substitution are important is that they both have the exact same first step. And the first step that they both have is a step that we have been talking about time and time again all the way through this course, is you have to get y by itself. Now you do not have to take it down to mx plus b, but you do have to be able to get it down to y by itself. For the graphing way, you're going to plug one equation into y1, the other equation into y2. And you're going to get out one of three pictures. You'll either channel your inner pirate and have X marks the spot, or you will have parallel lines, which means that there is no answer, or you will have one line lie right on top of the other line, whoops, and that is infinite solutions because they intersect everywhere. So graphical solutions, and in fact, like the idea of solving something graphically is such a fundamental skill in high school math. With my 30-2s yesterday, we were reviewing for the diploma. I'd say half the questions we did yesterday were y1, y2 intersect. Like we just did that concept over and over and over and over and over again. What's different in grade 12 is the types of equations you have. So they didn't have line equations, they had these things called logarithmic equations. And to get a logarithmic equation y by itself takes a new skill. But once they got the y by itself, they can just go right back to grade 10 and find the intersection point. So this idea of this being a core idea, that y1, y2 intersect will solve every single equation that you could possibly imagine, is true. You just have to learn how to get y by itself. So in grade 10, we learned how to get y by itself for a line. In grade 11, you're going to get y by itself for a curve. And then in grade 12, we take the lid off of it and huck everything possible at you. Okay, but the idea is y's by themselves, find the intersection point. That's the core idea. For substitution, what we do is the understanding that if we can write the same thing on the left side, aka y equals y, then we can write the same thing on the right side. So we can make the two right sides equal to each other. And then we go ahead and we just solve it like you did back in junior high. This is called an algebraic solution. So my grade 12s yesterday, half the questions we did were solving graphically. The other half of the questions we did were solving the algebra. But the algebra that they were learning or doing was not grade 8 algebra, it was grade 12 algebra. They had learned some new skills this year and they were practicing that. But literally the lesson I'm doing with you was the exact same lesson I did with them yesterday. It's just with different types of equations. But the idea is there. You make the right sides equal to each other and you solve for x. You make the two y's equal to each other and you find the intersection. That's the core idea. And it doesn't matter whether you have lines or curves or whatever. So in grade 11, your systems are going to look like this. You're going to have a curve and a curve. And you're looking for the two intersection points. That's it. It's the same idea. Okay? So we're just going to do a couple questions solving graphically. We'll do a couple questions by substitution, and then that's it. You do not have to know elimination. You do not have to know problem solving. Okay? So there's two types of questions with solving graphically. There's the easy ones that already have the y's by themselves, and the harder ones where the y's are not by themselves. Okay? So just to note, putting in garbage gives you out garbage, right? We've talked about this countless times. So for this first one here, it's -1/2 subtract 1, and then 1/4 subtract 4. So making sure you use the negative key versus the subtract key. So if we just go through, whoops, did not mean to hit that. Okay, I'm just going to have to, why is this not? Okay, give me a quick second here. Okay, so um, just one thing here. Does anybody have on their calculator the plot 1 in big black bold? Has anybody got this bolded on their calculator screen? Okay, if you're borrowing a calculator from me and this plot 1 is bolded, it actually turns off all the graphing features and you'll just get nothing but errors on your calculator. So what I mean by that is that if your calculator looks like that, you can't graph anything on it. So does anybody have that on their screen right now? Okay. Okay, so plugging these equations in. So we've got negative 1/2 x subtract 1. So negative 1/2 x subtract 1. And then the other one, whoops, is 1/4 x subtract 4. So you don't need to have brackets around the 1/4. If you wanted to, you can, but you don't have to. Okay. So we should end up with 2 lines. Oh, okay. So my window settings are messed up from my last class. So the way to return the window settings back to normal is zoom 6. So zoom 6 returns them back. Hi. Tie-dye or neon, head on out to the hall. So we can see that this one is X marks the spot, right? We can see that the lines cross. So you are required to plot 2 points per line. So if you go second table, so second graph, here's where your table of values are. Okay, so try to pick integers as best you can. So from my first line, okay, so xy, so I'm going to pick 0, -1 and 2, -2. Okay, so 0, -1, 2, -2. So 0, -1, 2, -2. So there's my first line. And then to get the second line, again, you ignore the middle column and you pick an xy from the first and last. So if I go with 0, -4 and 4, -3. Remember, you can go up and down the table to your little heart desires. Okay? So 0, -4, 4, -3. So 0, -4, 4, -3. And then beside the question, we need to give the intersection point. So to find the intersect, you go second trace. Which one do we pick? 5. And then this one's super easy. What do you do? Enter, enter, enter. So 4, -3. Okay, so that's level 1. Okay, is plugging them into y1, finding the intersection point. The second question's a little trickier. The second question, we have to get y by itself. Okay, so I've got a plus 3x. How do I move a plus 3x over to the other side? Minus 3x. Okay, now when I remove that, you're left with a -2 in front of the y. How do I remove that -2? Divide. So I've got y equals 6 minus 3x over -2. So when you plug that into the calculator, we can use brackets. And if you want to, you can do feel the love. So you can go 6 over -2 and -3 over -2. So if you want to do that, you are more than welcome to, but you're not required to. The other one's a little easier. What's the only thing I need to move here? The x, and how do I go about doing that? Minus it. So I've got y equals 2 minus x. So there's our y1 and y2. Okay. So again, 6 subtract 3x divided by negative 2, and 2 subtract x. Okay, so 6 minus 3x over negative 2. And then the other one was 2 subtract x. Okay, so 6 subtract 3x divided by negative 2, and 2 subtract x. So let's see what happens. So again, x marks the spot. Okay, so plotting 2 points per line. So for the first one, I'll go with 0, comma, negative 3, and 2, comma, 0. So 0, comma, negative 3, and 2, comma, 0. For the other one, again, remember, ignore the center column. So I'll go with 0, comma, 2, and 1, comma, 1. So 0, comma, 2, and 1, comma, 1. Oops, a little off there. Now, when you look at this, can you already tell what the answer is? Where are these two going to intersect? 2, comma, 0, right? Even if you look at the graph, right here at 2, comma, 0. But having that calculate button available to you just is that nice confirming nod that you do know what you're doing. Okay. So again, 2, comma, 0. So all I'm saying to you is that in grade 11, you're going to switch from lines to curves. So instead of having one intersection point, they might have 2 intersection points or 3 intersection points. Like in grade 11, your pictures could look something like this. You could have a lot with that, and you find those. Or maybe it's this and that, and you would have that intersection point. Like, as long as you have 2 things that you can plug into the equation, to your calculator, the calculator will find the intersection points. It doesn't care about the shape of the graph. It just cares about where they intersect. Okay, so substitution, again, there's an easy and a hard. So the easy ones have y's by themselves, the hards do not. So for the easy, since the left side is already the same, we can make the right side the same. Because if the left side is the same, we can assume the right side is the same. So we've got negative 4x plus 5 equals 3x minus 9. And again, this is called substitution. That's this method. Okay. So once you have it to this stage, you're literally just going to go back to grade 8. X's to one side, numbers to the other. Now again, it doesn't matter if you bring the x's to the left and the numbers right, or the x's to the right and the numbers to the left. Doesn't matter. For me, I prefer to bring the small x to the side of the big X. So negative 4 is smaller than positive 3, so I'm going to move the negative 4 by adding 4. Now I'm going to add 9 to both sides. So 14 equals 7x. So x equals 2. Now, are you done once you found x? What else do you need to do? Find y. Okay, so which equation looks easier to you, the top one or the bottom one? I would say the bottom. So we've got y equals 3x minus 9. So my x is 2. So y is negative 3. Now, there is nothing stopping you from checking on your calculator. You could plug this into y1, this into y2, and they'll intersect at 2 comma negative 3. There's nothing stopping you from doing that. We're just wanting to see the algebra. Okay. Okay, so the harder one, again, it's the same first step as with graphing. You've got to get that y by itself. So if you're struggling with getting y by itself, now it's affecting you in the graphing way and the substitution way. So you're being hit in multiple ways with that. Now for this first one here, there is a -1 in front of that y. I strongly encourage you to write those ones in there so that you can remember what you're doing. So I'm going to minus the 1x from both sides. That leaves me with a -1 in front of the y. So now I have to divide by -1. So there's the first one. For the second one, I'm going to minus the 3x from both sides. That leaves me with a -2 in front of the y. So I'm going to divide everything by -2. There's the other one. So now we've got the same thing on the left. So if the left side is the same, then we're going to make the right sides the same. And the way we show that is to make them equal to each other. Okay, so you make the left sides the same, so then the right sides are the same. So in grade 8, you called this a proportion. And the way you solve a proportion is to cross multiply. Now it doesn't matter which diagonal you do first, it's entirely up to you. So 2 times -2, -1 times -2, -1 times 6, -1 times -3. Okay. At this stage now, x is to one side, numbers to the other. So I've got a 2x on this side and a 3x on that side. So I'm going to move my smaller one. So 3 minus 2 is 1x, or just 1x, or just x. I'm going to add 6 to both sides. So x is 2. X is not always going to equal 2. It's just a happy little accident there. Are you done once you've solved x? Nope. Which one do you want to use for, which one seems easier? I would say the top, right? So x minus y equals 2. So think about this. 2 minus y equals 2. 2 minus what is 2? 0. Just use your common sense. You don't always have to do algebra. Okay? So those two lines would intersect at 2, 0. What's wrong? Did you still get the same answer? That's fine. That's fine. It just, okay. Questions on solving by substitution. So is substitution longer? Yes. Okay, so do you remember what we did yesterday with solving quadratics by factoring? Right? X squared plus 7x plus 6 equals 0, and you factored, okay? Here's where this is going, and this is mainly for you kids going into 20-1. What's going to happen to you next year is when you get y by itself, and you make the left side and the right side equal to each other, when you make those two things, instead of having fractions, you're going to have an x squared and x and a number, and x squared and x and a number on both sides. So what you're going to have is a quadratic equaling a quadratic. Well, what's the main rule of quadratics? They have to be made equal to 0. So what's going to happen in grade 11 is you're going to bring everything over to one side and make it equal 0. And now you're going to either plug it into your calculator or you're going to factor it. So you know how I said yesterday how most things in math boil down to quadratics? This is what I'm talking about. You're in the systems unit, but when you manipulate the equation, you end up with a quadratic. And so now you're going to have to use one of those quadratic methods that we've already practiced, either the graphing or the factoring. Okay. Where the confusing part comes is that you're going to learn 2 more quadratic ways. You're going to have 4 tools in your tool belt. Okay? Okay, trig. So our last unit that we're reviewing was the first unit we did in the course. Okay? So first thing we need to talk about is your calculator. So when you walk into your final next Wednesday, your calculator will be cleared. When your calculator is cleared, it automatically goes to radian mode. So the first thing you need to do, and I will remind you of this, but you need to put yourself into degree mode. So how you do that is you hit your mode key, you go down, find the word degree, hit enter, and then quit out. Now when you hit mode again, degree is highlighted. If you do not do that, your entire trig section will be wrong. Every single answer will be wrong. Okay? And they will be really wrong. Like you're looking for the height of a tree and you get negative 2.3 feet. Like they will be really wrong. And you should realize that this is not right. Okay? Have I had kids do the entire trig section of their final in the wrong mode? Yes. And it costs you an immense amount of marks. So don't do that. Okay? Put your calculator into degree mode. Okay. So the key word is SOHCAHTOA. Okay? SOHCAHTOA. So S stands for sine, C stands for cos, and T stands for tan. Now, trig is the only unit in all of high school math that exists in -1, -2, and -3. So if you're planning on going, you know what, none of this matters to me, Shonor, I'm just going to take -3 next year. No. Trig. Okay? Trig is the universal math that we have in high school. No matter, and this because most careers, most fields have some sort of trig involved in them, whether it be from construction to engineering to design to architecture. The only career I can think of top of my head that doesn't involve the concept of trig is accounting. But if there's design and features involved, or construction, and especially if you're doing a trade, welding, mechanics, all of those heavy trig. And the thing is that in the trades, you have to take the apprenticeship exam. The apprenticeship exams, while they are trade specific, they are still generalized skill set. You have to write the trades exam for each level that you want to go through, and there are 5 levels. They have a 70% pass rate. So if you do not get a mark of 70%, you have to take the test again. If you fail it 3 times, in other words, a mark under 70, you have to start all over. They kick you back to the beginning. Yes. And so trades, when people say, oh, I'll just go into the trades, Trades is much higher failure rates than most post-secondary programs because the pass rate is a 70, not a 50. And in fact, in most university classes, pass rates aren't even 50, they're like 30 and 40 because they're marked on the curve. So, yeah. So it's actually much harder to go into trades than it is to become a teacher. Okay, so we have our little symbol, theta. Theta is what we use for finding angles. We never use it for side length. Theta tells us where we're going to stand. You need to know where you are standing in order to be able to label the sides. Okay? So how do you know where you're standing? Well, there's 2 options. You either stand at the corner that you're looking for, or you stand at the corner that you know. So if I tell you that this corner measures 36 degrees, then that is where you stand. If I tell you this is the corner I want you to find, then that is where you stand. You either stand at the corner you know, or you stand at the corner that you're looking for. You are never allowed to stand at the 90. Okay, that's a big no-no. So the next thing we did is we labeled the sides. So across from the box is always the hypotenuse because it is the longest side. Wherever we are standing, the side right beside us is called the adjacent side. Adjacent is just a fancy way of saying right next to you. So you guys sitting in shoulder buddies, your shoulder buddy is adjacent to you. And then all the way on the other side is what we call O, or O for opposite, because it is opposite where you are standing. So you'll only be able to write 2 letters down on your page. You will never be able to write 3. Okay? If you can't figure out the O, A, and H, you cannot do trig. It is that simple. So if you label wrong, you're going to pick the formula wrong. If you pick the formula wrong, it's all over. Okay? You have to show your setups. Setups are worth 1 mark. The answer is worth the other mark. So you have to show your setups. We're going to go through some core examples here, but just as a quick review here, when you're looking for the angle, you're going to hit second. When you're looking for the side, you're going to cross multiply and divide. Okay? So we're just going to do a few examples, refreshing your brain on this. Now, when we did trig the first time, we spent about 3 or 4 days learning the basics, like how to find a corner and how to find a side. And then we spent an entire week on all the different types of problem solving. Again, we're just going to go through the basics. We're not testing you on the entire kit and caboodle. We are just doing the basics. Okay? So let's just dive in and do some questions, and hopefully this comes screaming back at you. So the first 2 we'll do are finding angles, the second 2 we'll do are finding sides, and then we'll do a couple of tiny problem solvings to kind of wrap it all up. So if I'm looking for an angle, that means that is the point at where I'm standing. So I'm going to stand here, and I'm going to stand here. That is where I'm standing. So that's step 1. Step 1 is figuring out where you're standing. So you're going to stand at the corner that you're looking for. Step 2, you're going to label your 2 sides. I usually do the hypotenuse first. So across from the box, that's my hypotenuse. What is the 6? It's all the way on the other side, so it is opposite. If I look at the other one here, across from the box, there is no number here, so do not put an H down on your page. So there's nothing on the hypotenuse, so don't write down H. The 16 is all the way on the other side. It's opposite. 4.7 is right beside me, so that is adjacent. Okay, so SOHCAHTOA. Okay, so go through the 3 parts looking for the O and the H. Where do you see the O and the H? Right here, right? You see the O and the H. So your setup is sine theta equals, and then over here, you're going to put your sides. So it's opposite on top, hypotenuse on the bottom. So opposite on top, hypotenuse on the bottom. I need to see that on your page. I need to see that exact thing. Sine theta equals 6 over 12. And then the next thing you're going to show me is the answer. So on your calculator, when you're looking for an angle, this is when you hit second. So when you're looking for an angle, you hit second. So you're going to go second sine 6 divided by 12. Finish off the bracket, hit enter. You get 30 degrees. Okay. Now don't forget about your degree symbol. Those are your units. We've talked about the importance of units this year. Okay? So make sure you put that little degree symbol there. So for this other one, this one has the opposite and the adjacent. So which part of the formula is the O and the A? Where do you see OA? Tan, right? There's the OA. So we write tan theta equals, it's opposite on top, adjacent on the bottom. So opposite on top, adjacent on the bottom. So again, I need to see that on your page. So your calculator is second tan, 16 over 4.7. So typically with corners, we rounded them to whole numbers, whereas sides, we kept one decimal place. So what would that round to as a whole number? 74. And then don't forget your degree symbol. Okay, so 2 marks per question. 1 mark for setup, 1 mark for answer. Questions on finding an angle. Okay, finding a side. We do it the exact same way as angles. It's just the button pushing on the calculator is what's going to be different. So this time, instead of standing at the corner you're looking for, you're going to stand at the corner that you know. So this is where I'm going to stand. This is where I'm going to stand. Because you're not allowed to stand at the 90. Okay. So we're going to stand right here. Okay. So stand at the corner that you know. Same thing. Label your 2 sides. So across from the box, that's the hypotenuse. All the way on the other side, that is opposite. Here, across from the box is the hypotenuse. All the way on the other side is opposite. I didn't mean to do 2 of the same, but whatever. Okay, which one is O and H? Is that sine, cos, or tan? Sine. So it's sine. Now, sine 75 equals. So you put the angle here. So the angle always goes on this side. The sides always go on this side. So sine 75 equals. So it's SOHCAHTOA. So it's opposite on top, hypotenuse on the bottom. So opposite on top, hypotenuse on the bottom. Now, with these ones, I had you insert an over 1. Just pause here for just a second. Okay, let's go back to this slide right here. Solving by substitution. When we have 2 fractions equal to each other, what do? Cross multiply. Whoops. Do we have 2 fractions equal to each other? Yes. So we cross multiply. It's just in this, because this is what I'm looking for right here, we changed it from cross multiply to cross multiply and divide. But it's the same idea. Okay? So how do you know what to multiply? You multiply the one that doesn't have the x. So this diagonal has an x, this one does not. So that gets multiplied. Now, this is where some of you stumbled. You have to do the multiply first. So on the calculator, you are going to go 1 times 6. You have to do that first. Then you do the divide. So you always do the multiply first, the divide second. So 1 times 6, divide by sine 75. You do not hit second because you're not looking for an angle. So 1 times 6 divided by sine 75. Okay? So cross multiply, then divide. So nearest tenth, 6.2. Now, a couple things with this. We were looking for the hypotenuse. What do you know about the hypotenuse compared to the other sides? It has to be the longest. So if I'd ended up with, let's say, with 4.7, do I know I've screwed up? Yes. Okay. Okay, this guy. So again, we know we're dealing with sine. So it's sine 66. So again, this is the angle equals the sides. So it's opposite on top, hypotenuse on the bottom. So x over 3. Stick that over 1. And again, this is your setup. We want to see that. Now this time, what way does the diagonal go? Which one does not have the x? That one. The other one has the x. So again, we're going to multiply. Multiply always comes first. So we're going to go sine 66 times 3. Then we do the divide by 1. Okay, so you do the cross multiply first, then you do the divide by 1. Now, when I hit sine, what immediately appeared on my screen? A bracket. So when I go 66, you have to finish off that bracket before you do the times 3. If you don't finish off the bracket, you'll get out a wrong answer. You will not get out an error. You will just get out a wrong answer. Okay, so this bracket right here, that has to be there. Okay, so 2.7. When you come back from break, we'll do a couple more of these, and then you'll get some work time. Be careful of the cord, please, when you're walking across. Okay, let's do a couple of little problem-solving questions, and then we're going to call it a day. Okay? So the problem with the problem-solving questions is if you interpret them wrong and put the numbers onto the wrong spots of the diagram, then your setup will be wrong. And if your setup is wrong, then it's just all plain and simply wrong. So we've just got to be really slow when we read here so that we have an idea as to what we want to do. So it says a tower casts a shadow that is 60 feet long with the angle of elevation of the sun is 65 degrees. So you've got this tower. Okay, so there's a tower, and it casts its shadow here. Okay, so here we can see this is our right angle triangle. Okay, so we spent a fair bit of time talking about angles of elevation and angles of depression. Essentially, the angle of elevation is from a horizontal line up, and the angle of depression is from a horizontal line down. Now, angles of elevation and angles of depression are the exact same number. You can plunk them in either spot. So here, from my horizontal line up, that is my angle of elevation. Okay, so from a horizontal line up, that's where that goes. Now, a tower casts a shadow that is 60 feet long. So the shadow is 60 feet long. That's that. And the question is, how tall is the tower? So once you have the information filled in, you now go through the same process as before. So this is where I'm standing. So you stand at the corner that you know. You label your two sides. So we're across from the box. There is nothing there, so don't put the letter H down on your page. The 60 is right beside you, so that is adjacent. The X is all the way on the other side, so that is opposite. So which of your three? Is it so, pa, or toa? Toa, right? We've got the O and the A. So it's tan 65. So it's OA. So opposite on top, adjacent on the bottom. So it's always angle equals sides. So put that over 1. Find the diagonal that does not have the x. The diagonal that does not have the x is that one. So that is what we're going to multiply. So we're going to go tan 65. Make sure you finish off that bracket. Times it by 60. And then divide by 1. So tan 65 times 60, divide by 1. And again, do not hit second because you're not looking for the angle. Okay, so nearest tenth, 128.7. And then this time, you put your units in because the question did give it to you in feet. So the answer is going to be in feet. Okay, one more. Matt is standing on top of a cliff 305 feet above a lake. Okay, so we got a cliff. We got Matt. We got a lake. Okay? So the cliff is 305 feet. The measure of the angle depression to the boat on the lake. Okay. So here is my triangle. But here's the problem. The angle of depression. So from a horizontal line down, that is the angle of depression. So this right here, where am I at here? Okay, this right here, that is not 42 degrees. That is not the angle of depression. The angle of depression has to be from a horizontal line coming down to the hypotenuse. Now, because it is outside the triangle that I want, and because angles of depression and angles of elevation are the same, we can just follow the z. So if you follow the z, then if this is 42, we can assume that that is 42. Angles of depression and angles of elevation are the same number. Think about it. If this boat is not moving and Matt is not moving, the angle to which Matt looks at the boat is got to be the same angle that the boat looks up to Matt. They have to be the same number because nobody's moving. Okay. So the question is, how far is the boat from the base of the cliff? So you are looking to that. So the key on this question was making sure that you had that 42 degrees in the right spot. So standing here at 42, because that's where the corner is, the x is right beside you, so that is adjacent. The 305 is opposite you because it's all the way on the other side. So O and A is tan. So opposite over adjacent. So put that over 1. The diagonal does not have the x. So that would be that guy. So on your calculator, you're going to go 1 times 305. Remember, you have to do the multiply first. So 1 times 305, then you do the divide. You have to do the multiply first. You have to do the divide second. So again, if you do it in the wrong order, you're not going to get out an error. You're just going to get out a wrong answer. So 1 times 305 divided by tan 42. Work it out, 338.7. So that is how far the boat is off the shore. So again, what you're being marked on your setup and your answer. You do not need to show me how you're button pushing into the calculator. Okay, we have one day left, tomorrow. What I'm going to do with you tomorrow, because Trig is in all 3 grade 11 courses for math, what we're going to do tomorrow is we're going to introduce you to what happens if you don't have a right angle. If you end up with a triangle that doesn't have a 90-degree corner, you cannot use SOHCAHTOA. You cannot. It's like, well, I'll just use it and the answer is close enough is good enough. No, no, no. You cannot use that. So in grade 11, you learn 2 new trig formulas. Okay? We're going to do one of them. We're not going to do both. We're just going to do the first one. Yep. Yes. Yeah. Okay? So here is what we have done. We have now done questions 1 to 12 on the final. The only thing we have not done is question 13 on the final, which is what we're going to do tomorrow. Okay? So tomorrow I'm going to show you a new trig formula. It is ridiculously easy. All it is cross multiply and divide. That's it. And it gets better. When we remove the right angle from the triangle, you no longer have to know opposite, adjacent, and hypotenuse. So if that OA and H is what's bugging you about trig, you are going to love grade 11 trig because you don't have to worry about OA and H. It's just we give you a formula, you drag and drop the numbers in, and you punch it into the calculator. Okay, so most kids actually find grade 11 trig easier than grade 10 trig. Okay, so this is where we're at. Okay, we have covered all but the last 9 marks on the exam. Okay, so in terms of your homework booklet, in your homework booklet, you can do everything from question A all the way to P. Okay, A to P. Whoops. So in your homework, you can do A to P. Okay, so you've got about 40 minutes here today to work on this. Tomorrow, the sine law, it won't take very long to do. It's our last thing that we're going to do, the little bit of new trig. The last question on your final. So you're going to get a good chunk of time tomorrow to practice. Thursday and Friday are complete practice days. So I'm not doing any review, any teaching at all on Thursday and Friday. If there's a version 2 that you're wanting to do now that you've had a week and a half of extra practice time, tomorrow and Thursday and Friday would be a good day to do those version 2s. And then that's it. You are done and done. So you got one more lesson left tomorrow, and then the time is yours. Okay? So do make sure that when you get to the trig section here, okay, make sure that you're in degree mode. That's the only thing.